Okay, so good afternoon. Welcome to Sagamata Online Academy. In today's video, I want us to look at stereochemistry. Stereochemistry. This is lesson 2 in the series of 10 lessons in this topic. This is basic organic chemistry for those who are in second year at Cherembana University. I think this is the course that they do. From other universities, it might be done in second or first year or third year, depending on the arrangement of the university. So stereochemistry is one of the topics that we need to cover in organic chemistry. Okay, so today I would want us to look at the naming system, the RS naming system of stereochemical compounds. The RS naming system of stereochemical compounds. That's what I want us to discuss. So I want us to discuss the RS naming system. Naming system. How do we assign the RS naming system? Okay, so for us to be able to understand the RS naming system of stereochemical compounds, or which is simply the configuration, I want us to look at some few rules that we need to bear in mind so that we clearly know where we are heading to. Okay, so I decided to summarize these rules so that it will help you to be able to follow and be able to understand the concepts being presented to you. So number one, what we need to know is that when naming stereochemical compounds, we use what we call a Can-Ingold prelog system. We use what we call Can-Ingold prelog system. This is a system that we use to name stereochemical compounds. So number one, let's look at the rules. Number one, atoms are ranked according to their atomic numbers. So we're saying that the atoms that are there are ranked according to the atomic number. So in other words, what we're trying to say here is that if you have got, let's say, 4 atoms being connected to a single carbon, and that carbon is called the stereogenic center or the chiral carbon. So the atoms that are surrounding the carbon, the way we assign priorities, the one which has got the highest atomic number is the one that should be numbered number 1. It has to be given number 1. It has to be assigned a number which is 1, representing that it's the one which is having the highest atomic number. So that's number 1. And then number 2, you have to ensure that number 4 is in the back. You have to ensure that the atom that you have numbered 4 is in the back. So we're going to understand what we mean by that. And then number 3, you need to cross out, or you need to cancel 4. So number 4 has to be cancelled. And then once you have cancelled it, that's when you can also proceed. And then number 4, you have to trace an arc from 1 to 2 to 3. And once you've done that, you should be able to tell which one is R and which one is S on the compounds that you're trying to name. Now, in order to understand this, let's take an example. So let's take an example. Let's say you are naming this compound here. Let's begin with a simple one before we advance, so that we can set a foundation for this. Okay, so this is a compound. This is a compound that we need to name. This is a compound that we need to name. Now remember, we're saying that we need to assign priorities depending on which one has got the highest atomic number. So in order for you to know which one has got the highest atomic number, you need to look at the periodic table. You need to have a periodic table with you. so that you understand and so that you see which element has got the highest number. So in this case, I have mine here. So remember that the elements that you have here are bromine, iodine, hydrogen, and you also have a substitute. You also have a group here, which is a methyl group, which is here. So in this case, we are considering carbon, which is connected to this carbon here. So it's carbon to carbon. So among the four, bromine, iodine, carbon, and hydrogen, which one has the highest atomic number? So you find out to say that iodine is the one which has got the highest atomic number, because the highest atomic number, because the atomic number for iodine is actually 53, and the atomic number for bromine is actually 35. And if you look at the atomic number for hydrogen, it's simply 1. And if you look at the atomic number for carbon, the atomic number is actually 6. So of the 4, you discover that iodine is the one which is bearing the highest atomic number. So you're going to number this as 1. And of course, what follows here is number 2, which is bromine, which is having an atomic number of 35. And then from there, between carbon and hydrogen, you'll find out to say that carbon has got the highest, has the higher atomic number than hydrogen, and therefore this becomes 3, number 3. Remember it like this, and this one is number 4. Now remember, according to our rules, we said that number 4 has to be cancelled out. So we're going to cancel out like this, and once you've done like that, you need not to draw an arc from 1 to 2 to 3, and then from there you should be able to assign the configuration to this. So if you draw it like this, 1, 2 to 3, so you see that you're moving in a clockwise direction. You're moving in a clockwise direction. So if it's a clockwise direction, it's actually R. The configuration is R. But if it's anti-clockwise or counterclockwise, or should I say anti-clockwise, the configuration is S. So in this case, you're moving from 1 to 2 to 3, and the direction that you're taking is that of a clock. This is clockwise direction. So therefore, this configuration is R. So this carbon here is bearing a configuration of R. So this is how you assign the RS configuration to stereochemical compounds. That's number 1. Let's take another example in order for us to be able to understand this. What if we say, what if we do like this? What if we do like this? What if we do like this? Okay, we do like this, and then let's have our OH here, like that. So the question says, identify the chiral center, and assign RS configuration, That's the question that we've been given. How do you go about this question? That's the question. Now remember that the chiral center is actually a situation where you have carbon being surrounded by 4 different groups. So you can have A, B, C, D. These are groups, and these groups are not the same. So because these groups are not the same and all of them are connected to the same carbon, this carbon here that is at the center, we say this is a chiral molecule. And this carbon that bears these 4 groups is called a chiral center. So they want you to identify the chiral center in this compound. Now, let's go ahead. Remember that here you have got an invisible hydrogen. Why? Because carbon should have 4 bonds around it for it to be stable. So meaning you have 1, 2, 3, 4. So it is stable. So in this case, here you have a hydrogen, another hydrogen, another hydrogen. So 3 of them. 3 of them. Here there are 2. Here there are 3 as well, like this. So this is the compound that we have. This is the compound that we have. Now, the question is saying identify the chiral center and assign the RIC configuration. This can be chiral center because a chiral center should have 4 different groups. And in this case, you have a carbon here bearing hydrogen, 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 3 of them. So this carbon here is not a chiral center because it bears 3 different groups. So therefore, this carbon here is an achiral carbon. Okay, it's an achiral carbon. Same here, this is an achiral carbon. It's not a chiral carbon because it bears 2 hydrogens that are the same. Let's look at this one. This one also is not a chiral carbon because it bears similar groups here, hydrogen, 3 hydrogens. But if you look at this one qualifies to be it qualifies to be a chiral carbon. Why? Because it has got 4 different groups. So you have got 1, 2, and this methyl group and this ethyl group. So there are 4, all of them connected to this carbon here. So how do you assign the priorities? Now remember that this carbon is directly connected to hydrogen here and also directly connected to oxygen, and it's connected to this carbon here and also this carbon here. So in this case, oxygen, the OH group, the hydroxyl group, is going to get number 1. So to be assigned that one, that number there, which is 1, because it is the one which has got the highest, priority, or the highest, should I say, atomic number of the 4. So in this case, we are going to have now a tie between this carbon and this carbon because all of them are carbons connected to this. So which one are we going to number? Which one are you going to assign to? So in this case, let's look at what is connected to these carbons, this carbon and this carbon. So let's look at what is connected to each of these carbons. So here we have another carbon connected. Here we only have a hydrogen connected. So therefore this one is going to win over this carbon here. Why? Because this one is connected to the carbon which has got the higher atomic number than this hydrogen. So therefore this is going to be 2, and therefore 3 and 4, like that. According to the rules, you cancel out number 4, and then you draw an arc from 1 to 2 to 3. So you draw like this, like that. So what direction are you taking? This is a clockwise direction, and clockwise direction is associated with the error configuration. So therefore, this is the error configuration. Now, we're not going to pay attention to this because the group number 4 is pointing away from you. How do we know that it's pointing away from you? If it is on the dashed bond, this is called this is called a wedged bond, and this is called a dashed bond. Dashed bond is this one which has got dots, and the wedged bond is this one which is solid. So this one is a dashed bond, as you can see, it has got my dash like this, and this one is called a solid bond. So this one is called a solid bond, and it's also called a wedged bond. So if it's on the dashed bond, it is pointing away from you, but if it happens to be on the wedged bond, it is pointing at you. So that's the language that to use. So this one is pointing away from you. So because it is pointing away from you, you're going to maintain the arrow. So this is the arrow configuration. Therefore, I think this helps. Do well to share the video so that those who are in it will be able to, have will be able to obtain some knowledge from this and help them to be able to understand some of these things that we're discussing here. Thank you so much, and please do well to follow us on YouTube. Simply type Succumb Online Academy. You'll be able to get hold of the channel. And please do well to subscribe so that every time a new video is uploaded, you'll be able to get a notification so that you watch it. Thank you so much. This has been Sam Temano. Thank you so much. I really appreciate the support. Thank you.